All right, welcome everyone to the third boot camp for the Geothermal Datathon. Today speaking with us, we have Andy Adams. So he is a technical project manager for Boston Government Services. So he's a contractor to DOE's Geothermal Technologies Office. He's a geophysicist and he's currently working with the Data Modeling and Analysis Group within the Geothermal Technologies Office to help increase the quantity and quality of data. He works on both the power generation and the heating and cooling space. So really, he's the nexus of the data operations behind this datathon. And he's especially he's been working especially on enhanced geothermal systems, such as including Utah Forge. And working with him has been a real pleasure this year, and I'm excited to hear what he has to say. So without any further ado, take it away, Andy.
Yeah. Well, thanks, Ben, for the introduction. You stole kind of my introduction, but I kind of prompted you to do so. So I appreciate that. So like Ben said, welcome to the third boot camp of the SPE Geothermal Datathon. My name is Andy Adams. We're all very excited about the interest that you have in learning more about geothermal, whether you're a petroleum engineer, computer scientist, geoscientist, or any other specialization. We really look forward to your participation in this competition. And my goal for this boot camp is to inform you all where the data for the Forge project is and answer any questions that you may have with downloading that data. So I put a link in the chat box. This is the link to the GDR website. And the GDR stands for the Geothermal Data Repository. And it's the submission point and repository for data generated by funds recipients of the US Department of Energy's GTO, Geothermal Technologies Office. And as of the end of last year, the GDR is home to over 1,000 data sets and over 140 terabytes of data. Not all this data will be used for the competition, so don't worry, we'll save you some disk space as this competition is focused primarily on the Forge project. Additionally, not all of the supplemental data for Forge will be found on the GDR. There are other sources, including research papers that may prove to be useful, and as well as the Utah Forge website itself. And there's also a wiki page that's useful. So you can reach the GDR following the link that I provided, or searching Geothermal Data Repository. It should be the first link that pops up in the search engine of your choice. And on the right is what the main page of the GDR looks like. So you have a few different functions from this main page. At the top left of the screen, you'll see the drop-down choices. You can query data through here. You can search all data sets using keywords. The help has some information about what kind of data is stored. So the GDR classifies data as tier 1, tier 2, tier 3, depending on if it's structured or unstructured data. So like I said, you have this data drop down. You can also use the search. So this is what the search looks like. You can also choose by technology types. So here you can see direct use, direct heating, EGS, hydrothermal, and then we also have our featured projects. So the thing about the featured projects, which is nice, is they are actually hosted on the front page of the GDR. And as you can see, the Utah Forge project is located right here. So when you click on the Utah Forge project, you'll be taken to the Forge homepage. And in this page, there will be animations showing microseismic locations associated with the stimulation of the 3 zones in the 5832 well. And if you press the play button, the microseismic events will populate the graphics in time as the stimulation plays. So this is kind of just a nice graphic that the Forge team wanted to provide you with in regards to 5832. The focus of this competition will not be on the vertical 5832 well, but will be on the 16A 32 well and the future 16B 32 well. So if you click on this Browse Utah Forge Data button, this blue button on the left-hand side, it'll take you to the bottom of this main page, where you can see all of the data sets that are associated with the Forge project. The GDR teams provided several useful links above that are hosted outside of the GDR for reference. Like I mentioned before, the Utah Forge website and the wiki. And then by standard, the submissions are sorted by submission date. So the newest submission will be at the top of this list. There's currently 148 submissions and over 200 gigabytes worth of data associated with the Forge project. And many of these submissions are zip files. So there actually could be more data than it's currently showed here. It actually counts the size. And if it's compressed, then this data size may be a little bit larger. But the data associated with Forge consists of many types of geoscience logs, including triple combo and quad combo logs, image logs, XRD data, core images. There's comprehensive drilling logs, including accelerometer data. There's also stimulation data, seismic data, tracer tests. Really, there's a large swath of information within this data set. The focus of this competition will be on the microseismic data and providing fracture interpretations. You may use whatever data is available to support your hypothesized fracture placements. And for the 16A32 well, there is injection pumping data that corresponds with the microseismic data files. So that may be useful as well. There's additional well logging, extensive modeling that's been done in the area, including discrete fracture networks, seismic velocity models, and native state simulations. And then there's additional data that you may find useful in your analysis, including contextual data, several GIS data sets, temperature gradient, geochemical data, grav mag data, seismic data, LiDAR, INSAR. So we really do have quite a bit of resources available to you. So if you want to focus on one specific well, in this case, I type 16A in the search bar here, it will sort the submissions still by upload date, but it will filter out anything that doesn't have 16A in the title, pretty similar to most querying type functions. So let's say I was interested in downloading these seismic related events to the 16A32 simulation. I would click on this submission name and it would take me to the download page. So here you can see the PI has entered in some information at the top, the revised catalogs of the 16A simulation for phases 1, 2, and 3. And it's a microseismic catalog. And you can see there's only one download available. It isn't a zip file, but it's the 3 stages are separated into Excel files. So it's simplified in that way. In other cases, you'll have multiple resources for a submission. So this example is 16A 7832. So there are zip files, there are PDFs, there's LAS files. In this case, you could still use the download button to download single resources, but you can also download all resources and that will zip all of these files into one download folder. So it makes it a little bit easy if you want to look at all of the data available and only have to click one download. It does take some time to compress it into a zip file, not a lot of time. Obviously, that depends on the size of the submission. But like I mentioned earlier, most data is related to the Forge project is housed on the GDR. But the Utah Forge Wiki is also a really good place for supplemental information. By clicking this link, it will take you to the Forge Wiki. So we'll go ahead and move forward here. This is the front page of the Forge Wiki. So it's got each well for the Forge project at the bottom here. It's got a general overview of the Utah Forge project. And a lot of these links will have additional links that send you back to the GDR. So here I clicked on the 16A 7832 well. It's got some general information regarding the well. So you can see it's got the TVD, it's got the wellhead location, you know, what dates, when the kickoff was done. And below you can get into a little bit more detail for each of the submissions related to the 16A32. So let's say I was interested in the drilling data for the 16A32 well. If I click that link, oh, I forgot a slide here, but if you click that link, it will bring you back to a page that's similar to this one. It will be the drilling data, but it will lead you back to the GDR where you can download that data. So this is really a good kind of roadmap to show you exactly where to find that 16A information. So we've given you a couple of different options of how to query the data. You can use the Forge wiki. You can use you know, search words that are pretty significant. The data that goes into the GDR is curated by the GDR team, and they pick out keywords that they find suitable and relatable to the data sets. So they make it pretty easy for you to find anything that you need. Like I said before, some of the most useful data sets that you'll be looking at will be related to the 16A stimulation. So here you've got 16A stimulation DFNs, seismic events. You'll also have the stimulation data. As you can see, that's the second from the bottom here. Here are some helpful links. Most of these I have gone over already, but the GTO office also has the Forge webpage that goes over the project at a higher level. It may not be as useful as some of these data resource links, such as the GDR, the Forge wiki, and the Utah Forge project website. But if you have any questions regarding Forge GDR or other DOE GTO related questions, especially regarding to the SPE Datathon, please feel free to send me an email. My email is andy.adams@ee.doe.gov. I'd be happy to assist you with any downloading and give you any more information about DOE's Geothermal Technologies Office, current funding opportunities that are out there, resources that are available even outside the Datathon. We really enjoy connecting with our stakeholders. And yeah, I know that we reserved an hour's time for this Datathon, but or for this boot camp, I should say. So if you have any questions regarding the GDR, please feel free to type them in the chat, or Ben use the hand raising question. Or hand raising button, not question.
All right, let's go to a question from Jeff Bailey.
Good morning. I understand from some other, I don't know whether it's publications or whatever, that there may be several different sources of time stamps. And can you address maybe the issue of timestamps in the different data sets?
So could you repeat that question? Are you saying the timestamps for the microseismic data doesn't match the stimulation data, or is it?
Well, yeah, so hold on 1 second. Sorry.
That's okay.
So the microseismic systems, need pretty good timestamps quality, but like how is that synchronized to the frac van and the timestamps in the frac van? I guess I read that there may be as many as 6 different timestamps.
Okay. I believe that the Forge team has QC'd that data and connected the microseismic data to the stimulation data for the timestamps. I don't have that data available to me right now, but I will look at those timestamps and verify that they are in the same time domain, and we can post that in the Slack if we need to edit any of the time domain files.
I guess when the microseismic data was analyzed to get all the different event locations that have been mapped, that would have been taken into account, but synchronization with the frac van time, is that something you might have information on?
Let me check with the Forge team and see if they do have that synchronization available. I would assume that they have that on the GDR as well, but if not, we will have them upload that or get a file for the competition for you all.
And I think I saw somewhere that they're continuing to analyze microseismic data for additional events.
Yes, that is a major focus of the Forge team right now, is really looking at the microseismic events to develop fracture models, and ultimately this is another iteration, another competition designed to navigate that problem, right? Because it's all about interpretation. And so our goal within the Datathon is to use machine learning and use data science to kind of guide our fracture visualizations. And so, yeah, this is something that the Forge team is currently working on.
Okay. Do they expect to have any updated results during the course of this Datathon?
So I believe that multiple Forge team members have, they did submit papers to the Stanford Geothermal Workshop, which is a publicly available, let me find that link for you. That is a publicly available, those are all publicly available papers. I just need to find that link for you. So just give me 1 second. I will post, so the link I just posted within the chat, that has all the conference papers from the Stanford Geothermal Workshop. There are some presentations that go over fracture visualizations, include planar modeling, DFN work. So those are some sources of the most up-to-date visualizations from their microseismic interpretations.
I'll make sure to post that link on the Slack so you can access it later.
And I guess the raw microseismic data is not posted to the Forge. I mean, that's huge volumes, right?
Yes. So these seismic events at the top, these are the seismic pics. I do believe that let's see here. I do think that they have the microseismic data downloadable, but it may direct you to a different data storage. So the GDR is capable of hosting quite a large volume of information. I think that most of the seismic events that are within the Forge data sets are picks, but you'll have to go into that a little bit more to see.
Mhm.
All right, thanks for the questions.
Yeah, if you have more, Jeff, please.
Well, I guess I was kind of curious. Most of the events were recorded on the deep string of was it 10 receivers?
Yes, that's correct.
And were there, for these arrivals, were there signals at some of the others to help with the location, or is it all from the 10?
That's a great question. I think that there is a report within Forge. I'm going to stop sharing my screen real quick and pull up. There is a fairly comprehensive report that Forge put out. Okay, I will share my screen again. Can you all see I pulled up the GDR website.
Yes.
So they did have a seismic workshop where the PIs and the subs got together and talked about the challenges with the seismic, because I know that some of the downhole seismometers did fail during recording because of the high temperatures that are related to geothermal.
Yeah.
And that report does go over those challenges, what mitigation is required going forward, what data is missing. And so that may be a useful report to review in regards to the seismic data.
Now that I'm seeing this page, well, what does it mean exactly, awaiting curation?
So awaiting curation means it's not currently downloadable. That is one thing. I don't know if I showed within the presentation, but if the data set is publicly accessible, that is available for download. If it's in progress or awaiting curation, those are not available yet because they are being curated by the GDR team to be uploaded to the GDR. So there is some information that will be unavailable during the competition. The status may change throughout the next 6 to 8 weeks. So you'll have to just check back if you do see something that's awaiting curation. And if you do have some data sets that you're interested in that are awaiting curation, I could reach out to the GDR team and see if they could expedite any of those submissions for download.
Okay, that'd be great.
All right, so one question I have for you. Typically we don't ask this of our bootcamp presenters, but would we be able to share your PowerPoint on the Slack? It's got a lot of useful links in it that people might want to have at their convenience later.
Yeah, I think that we can share this. I will double check with Kevin Jones, who is the program manager for EGS, but I don't think that there's any sensitive information within this PowerPoint. So I do think that we'll be able to share that.
Super. Let me know and I'll get it done.
Yeah, no problem.
Any other questions from anybody? I know this is an important but sort of a dense topic. If anyone's sort of questioning maybe where to approach this, I don't know, Andy. I think I would probably start at the wiki if you're feeling a little bit lost.
Yeah, I think the wiki is a good place to start, especially for the background of the project. The Utah Forge website is also a very good place to start, just to give you some background on the project itself and what the goal of the project really is. Because the Forge is, it stands for the Frontier Observatory for Research in Geothermal Energy. And it really is a research project. It's not necessarily built for production, and it's not a typical production EGS project. They're really testing all sorts of technologies, whether it's for stimulating the reservoir, drilling implications. They're really trying to cover all swaths of research with this project. So, but I would say if you are to focus on I would focus on the 16A support data and information, and ultimately the scope of the Datathon will come out in a couple weeks from now. But I would familiarize yourself with the 16A deviated well as a good kicking off point.
Right, I agree.
We don't actually have the challenge questions in front of us at the moment, do we?
No,
Right.
not yet.
Will we have a chance to have another meeting with you when we have the questions in front of us and maybe some time to look at the data?
So we are all available on the Slack channel for supplementary information, and we have some subject matter experts within that Slack channel as well. I think Luke Frash is in that, and he has put a lot of effort into the Utah Forge project, and he's currently a researcher with Los Alamos National Laboratory. And so he may be able to answer some of your technical questions without giving you the answers to the problem. He's a really good resource for that. So once the statement's out, we will certainly be available to discuss further. But any questions that do come through, we would like to make public to the other participants, just to make sure that this is a fair competition.
Additionally,
location-
about at the midpoint during the competition, we'll probably have a quick meeting like you're envisioning, just to make sure we're all on the same page. That'll probably be at the end of April, I'm thinking. It's currently unscheduled.
That sounds about right.
When will they start drilling the second well? I believe it's this spring, isn't it?
Yes, it is this spring.
And do they know the location that they want to put the well in?
I believe they have an idea, but like I said, this isn't necessarily a operational well. I think primarily their goal is to research connectivity. Obviously, these researchers have a placement idea in place. But like I said, I think most of that data should be publicly available on the GDR, even though it's awaiting curation. Any of the information that we are provided is subsequently uploaded to the GDR.
It looks like we have a question from Daisy Ning.
Hello, Andy. Thanks for the presentation. I have two questions. First is for the stage length of the well 16A. So I noticed that the stage length is about 1,000 feet, which is much larger than the traditional stage length that we use for unconventional reservoirs. So is this a purpose that why we use such a big stage length?
So that's a good question. I think there may be information regarding the answer to that. I don't know that off the top of my head, but my guess is that they put those large stages, those large stage distances in place so that they could really monitor the stimulation of the well, right? Because like I said, they're testing different technologies. They're going to be testing different proppants. They're going to be trying to isolate those stages as much as possible. So that's likely the reason for the stage distances.
So for the current stages, are they have been stimulated, right?
Yes, they have been
Okay,
stimulated.
I see. Okay, here comes second question. So I talked with some experts and was told that short circuit, shorter pathway for the water, that might be a concern. So meaning that if we have cold water injected here, and then there is a short pathway for water, and then it will not heated fully. So when we mention that this is a concern, do we have any ideas or any possibilities for us to handle this problem?
Yes, so that is regarding the scope. And so I don't know if I can answer that question directly right now. But in geothermal, short circuiting is a major concern. And obviously when you have short circuiting, you end up extracting heat from that short circuit much more quickly than the rest of, actually pushing the water through the rest of the volumetric rock. And that in the long term affects your power production. And so that's one of the challenges within this competition, but I can't get into specifics necessarily yet right now.
Okay, yeah, I'll think about this. Thank you.
Okay.
Thanks for that question. Anybody else? All right, well, thanks y'all for coming. I am going to end the recording and see you at the next boot camp.
Thank you, everyone.
Thank you very much.
Good luck in the competition.
Thank you.